Hello students, welcome back. Let us continue with the superconductivity. Today we are going to discuss about a very important phenomena exhibited by all the superconducting materials. The phenomena was first studied by scientist Mesner and it is known as Mesner effect. Let us understand what is this Mesner effect. Okay, let us take a superconducting material. This material, as we know, if we hold it at a temperature greater than critical temperature, it is no more a superconducting material, it is a normal material. Though the material is superconducting one, if you increase its temperature greater to critical value, then it acts as a normal material. Now let us apply the external magnetic field onto this. External magnetic field, the strength of the magnetic field can be understood by the magnetic lines of forces. So let me show the magnetic lines of forces which can enter the material also and which can be beside the material also. So these are the magnetic lines of force which are entering the material. That means there is magnetic field within the material also, there is a magnetic field around it also when it is in a normal state. Now let us take the same material, that is superconducting state material only, and let's hold its temperature lesser to the critical value of its temperature. Now when its temperature is lesser than the critical temperature, it is no more a normal material. Now it is in its superconducting state. It is a superconductor now. Okay, when we try to apply the external magnetic field to this, then these lines of force will not enter the specimen of this. The same material, when we hold it lesser to the critical magnetic field, the flux is thrown out of the material and the flux will look something like this. We mean to say that the flux exists only the outside of the material. There is no flux inside the material. The flux is, the magnetic flux is thrown out of the material when it is in its superconducting state. This phenomena was observed by the Mesner and it is known as Mesner effect. Okay, let's come back to the some of the basic what we have learned about the magnetic field. Whenever you take the magnetic flux are nothing but the lines of forces. It has the magnetic flux as B. The strength of the magnetic field is H external or H. If a material acquires the magnetic field or if it holds the magnetic field, we call it as the magnetic moment. So all these can be connected with one another such that the magnetic flux acquired by a material when it is in the normal state is equal to mu naught into H plus M, where B is strength of the magnetic flux, mu naught is constant, H is the external magnetic field and M is the magnetic moment. This equation holds good when it is in the normal state, but when the material is in superconducting state, inside the material there is no flux. So we can say the B is 0 at this region. So this is for the normal material. For superconductors, as the flux through the material becomes 0, B is equals to 0. Hence our equation will become equal to mu naught into H plus M is equals to 0, or H plus M is equals to 0 if I send mu naught that side, or H is equals to minus M, or M by H is equal to -1, which is known as susceptibility. If a material is having its susceptibility as -1, then that material is known as a dimagnetic material. Perfect dimagnetic material. So what happened in our case now? While discussing the Meissner effect, when the material is held at less than critical temperature, the superconducting material will not allow any flux to enter its body. Hence, the material is acting as perfect dimagnetic material as it has acquired susceptibility of -1. We know that the property of perfect dimagnetic material is they repel strong magnets. So this repulsion with strong magnets can be used for many applications. Hence, Meissner effect is used for two purposes. The purpose number one is to check whether the given material is superconductor or no. So how we are going to check that? Hold the material at normal temperature, the flux will enter the body. Same material when held below critical temperature, acting as a superconductor, flux inside the body is 0, which acts as the diamagnetic material. So we can check in this way whether the given material is a superconductor or it is a normal material. Also, it has a very important application in levitation, in a process or the phenomena known as levitation. Levitation is nothing but whenever such superconducting dimagnets produced due to the Meissner effect are brought in contact. For example, this is a strong magnet kept here. If we bring a small superconducting magnet or this material here, and this material will repel this strong material, so that there is a certain gap of the space between these two. So this is levitated, means lifted through a certain height by this strong magnet, which is getting repelled by this. This process is known as magnetic levitation, and this makes the superconducting material to have their important application in maglev vehicles. Maglev vehicles are the ones which these are nothing but the superconducting trains which will not touch the rail of the train but just float onto the rail. So if this is the carriage which will be having a superconducting material here, and if this is the rail, it will be levitated. This rail material will be acting as a strong magnet, and this will be acting as the diamagnetic material. There will be repulsion, hence the train is going to float onto this. So this Meissner effect has an important application in magnetic levitation, which is used in maglev vehicles. So in this video, we understand about the Meissner effect, where it says that superconducting material will not allow any flux to flow through them. Magnetic flux through the material is 0, and the material will act as the perfect diamagnetic material which repel strong magnets. Thank you.